Welcome to the stage, MongoDB Senior Vice President of Products, Andrew Davidson.
Wow. Thank you so much. Good morning and welcome to MongoDB.local San Francisco. I'll tell you, I've lived for the last 10 years of my life in New York City, but I was born and raised right here in the Bay Area. And to start the day with the sun rising over the Bay and to end it with the sun setting over the Pacific, this is a dream come true for me. Thank you all for being here in person. And a big thank you to our partners, Accenture and AWS, helping us make this possible. You, our customers and our community, you are our North Star. You are the critical fabric that allows us to understand where we need to go with our platform. And when we talk to you day in, day out, and of course, now we get a chance to meet you in person again, we learn exactly what needs to be fixed as we move forward. And over the last couple of years, we've all heard time and time again the same story. A digital-first transition has become an imperative to business success today. It was such a tough couple of years we've all experienced with the pandemic, with gaming and media companies experiencing levels of demand and scale that they've never experienced before, with retail companies having to become e-commerce experts overnight, with supply chain and logistics challenges like we've never seen before. Heroes emerged, and time was of the essence. And we heard from you over and over again that the fastest way to build was with MongoDB. That's because developers could experience meaning shipping faster. Product people could get to market faster, and executives could make decisions to avoid being disrupted, make decisions on a dime to make sure that they could stay current and do what they needed for their businesses. So why does MongoDB make it possible to move fast? Well, it's because since the very beginning, we've always been focused on one main thing, developer productivity. That's been the core ethos of our company from the beginning. And if you think about where developers spend most of their time, they're wrestling with state, with data. If you can remove the friction of working with data, you can enable developers to build and innovate faster than ever before. Legacy technologies have been holding us back from this possibility. And this is why MongoDB is so ridiculously popular, as you all know. It's all anchored in that first moment in MongoDB's journey, the core model, the document model that allowed us, developers, to have a data model that reflected how we think and code. Coupling that with where MongoDB was in those early days and where the broader cloud economy was, having a distributed system that democratized infrastructure as a service in its early days, combined with this incredible document model, is why MongoDB was consumed like crazy and has been for 15 years. Hundreds of thousands of incredible applications have been built by developers all over the world in those years. People said, this model, it's not going to be for mission-critical use cases, it's not going to be for scale, it's going to be a fad. We've seen the exact opposite. Developers said something different. You have built incredible things in those years. And developers continued to pull us. They said, it's not just enough to have this incredible data model and to have a distributed system. You need to make this something fully managed, expressed in the cloud as a truly declarative experience, globally available. We need to move up a level of abstraction. It needs to be easier than ever before to imagine, not just state in a certain shape in a document, but to imagine our database clusters in a certain topology anywhere in the world. Atlas has been a total inflection point for this company. It's the vast majority of our customers today. It's the vast majority of the growth. We have over 150,000 people signing up for Atlas every single month, and it's incredible. Some of those people are building some of the largest workloads in the world, and the full spectrum down to that solo developer learning to code for the first time. Every single month, full stadium-sized group of people signing up. Across the global Atlas fleet today, we're powering millions of operations per second. All day long, every hour of every day, you're interacting with that Atlas fleet. You're interacting with MongoDB-powered applications everywhere you go all the time. This is the digital economy in action. True global reach. In 2014, when we had our first conference, we had 1,100 customers. Today, we've got more than 30 times as many customers in over 100 countries around the world. And our employee count has grown by 10x in that same time, with employees in over 30 countries. So many incredible customers, every vertical, every use case, building every conceivable type of application. Examples like Q Health, enabling us to have proctored COVID tests in the privacy of our own homes at a time in which we all needed that in order to travel. Or Boots, a 180-year-old pharmacy in the UK that was able to transform into an e-commerce oriented company. Or Toyota, building their connected car platform. Or Verizon, powering their 5G edge scenarios all on MongoDB. Possibilities have been endless. Because of our growth and financial success, we've been able to make massive investments in R&D, year in and year out. Cumulatively, we've now invested on the order of $1 billion into this platform. And in this year alone, we'll be investing more than we invested in the first 10 years of the company's history. What I think is so special, frankly, about this company, and I always say this to my team, we're in mission-critical data software here. This is not the space that changes super fast. This is the kind of space where you have to have long-term strategic patience. We have to make long game bets, and we have to do many of them concurrently. And the fact that we're able to do that while continuing to invest in the core and make sure that it all comes together in a way that delights the developer cohesively and keep iterating forward, frankly, it's just rare to have a company that has that DNA and that ability, that appetite. I think we share that DNA probably with many of you here. And we're just getting started. You know, our mission is to empower innovators to create, transform, and disrupt industries by unleashing the power of software and data. And this has been inspired by everything that we've experienced over the last 15 years. We've seen it time and time again. The relational databases that we all came up with, they've just got too many limitations. You know, relational databases were born at a different time. In the 1970s, the key cost bottleneck in computing was the cost of storage. The key cost bottleneck in computing today is developers' minds. So we've seen that companies like Foursquare, servicing 100 million points of interest for worldwide partners that they service, they need a flexible, scalable, geospatial-oriented data model. Companies like Harness, building AI-enabled DevOps experiences, they need that flexible scale. Relational databases have just not been able to keep up. And what happens, we've seen this trend play out, where people will augment that core, those systems of record that they might have traditionally had on relational, by layering in custom or niche databases. Maybe a key value store over here for scalability and high availability. Maybe a search engine over there to make it queryable, make it come together. Maybe they'll layer in a caching system because now they've sprawled across multiple systems. They need to do that to make it fast. What's happening here is we're adding more and more complexity. And what we end up with is some complicated architecture like this. And I think we all have architectures like this. We're all sort of proud of having built this. It's something that we've put a lot of blood, sweat, and tears into. Of course we're going to be proud. But really, if we think about it and reflect on this, this is a disjointed developer experience. Developers in their applications are interfacing with lots of different engines, with lots of different APIs and endpoints. We're paying the huge synchronization tax. It's brittle, it's complicated. There's basically a lot of plumbing going on. It's hard to have operational or security standardization in this paradigm. Fundamentally, this slows down innovation. You can't move fast if every one of your applications has a bespoke architecture like this. We believe the market needs something different. And that's why we believe what the market really needs is a platform for innovation. We've talked about the challenges of the spaghetti architecture, all the plumbing. We believe that in order to move on from that paradigm, there are three key tenets of a modern data platform. The first is an elegant developer experience. The primary interface should be one that developers know and love, a modern data model, the superset data model. Behind that elegant developer experience, you should be able to support the broad variety of workloads that your applications need, the vast majority of use cases that the vast majority of each of your applications require should be able to be serviced by one standard system behind that elegant integrated endpoint. And this should all be available on a secure, multi-cloud, global foundation that gives you the elasticity that you need to keep building fast. This is why we conceptualize ourselves with Atlas as a developer data platform. We start with that document data model, the superset model. If you think about it, key value is a document with a single index. Relational is a flat document. Take that single document model, and behind it, drive the vast majority of workload types that are needed for modern applications. Operational transactional, search, analytical, and make it easy to integrate with the modern form factors that people are building their applications to conform to. Truly multi-region and globally distributed applications, mobile and device-first applications, serverless and event-driven. And do this on top of that elegant, secure, multi-cloud baseline. We've always, in my mind, been pulled by our customers to deliver this. But I think something really clicked with me early on in the Atlas journey, and I'd like to share a little bit, show some vulnerability and share something. I remember early on with Atlas, I was speaking to a global gaming customer, massive scale game, and they had an outage in a non-production environment. And I remember having this conversation with this customer and saying, hey, at least it wasn't an outage of a production environment. And he said to me in that moment something that stuck with me. He said, you don't understand. An outage in a non-production environment is an outage in our app dev assembly line. That's an outage in our ability to continuously crank forward and innovate and move our software forward. And it hit me in that moment that absolutely, a developer data platform is what you need to be operating as a software company today. If you're a small team building a single application, this is a great paradigm. But if you've got dozens to hundreds of microservices or app dev teams or two-pizza teams, having standardization of how they can conceptualize the superset of what they need on this safe and secure developer data platform foundation, it's a game changer for people. So, speaking of operating like a mature software company, a great example of this is a wonderful company called Intuit. I'm sure you all know and love it. Intuit's been a game changer for all of us to do our taxes and for enabling small businesses all over the world. To tell you a little bit about their story, I'd like to invite Barry Ruffner, Senior Software Engineer at Intuit, to the stage.
Hello, I'm Barry Ruffner. It's nice to meet you all. So I want to talk about, I've been with Intuit about 8 years. So during that time, we went from a lot of on-premise systems, a lot of servers and big environments, to being mostly on the cloud. During that, we started looking at how do we solve for compliance and security. So for the last 3 years, we've been working on a platform called our Automated Compliance Platform, and its main goal is to provide this ability to look at all of this data. And when I say all of this data, it's a lot. So during the first year, everything was going great, except then it wasn't. Our database wouldn't scale. We had a data store that was running, but it couldn't keep up. The indexes couldn't keep up. It was actually failing. It was crashing. It was, unfortunately, not keeping up with our input. Now, at that point, we said, well, we have a chance. So we started at an event that we call our Global Engineering Days. The Global Engineering Days are a chance for engineers to go after customer problems, specific customer problems that are usually complex or risky, and we wanted to find a novel solution. So we went from there and said, let's find a way to solve this. So we came up with a few challenges. So I want to go over those with you. Let's see, yeah. So our first challenge was we had a huge amount of I/O. And when I mean a huge amount, we have millions of objects. These are cloud, non-cloud. Think of lambdas and everything you could think of. All of them have a security implication or a compliance implication. And we have hundreds of checks on all of them. The next challenge was, how do we store this data? We wanted to store it for a long time. We wanted to store it in a way that we could get to it immediately. Freeform search, be able to drill into the data, report on it, use the data to solve our business problems. And then finally we said, well, we want to make sure that a developer, while they're still in the development track, while they're working on code, can see I have a security issue and solve it right then. We were waiting until the end of a quarter when audits came to actually have problems fixed. That's way too late. So that was our main problem, was looking at this data, we had a lot of issues. So from there, we developed our platform, which had a few simple tenets. First was pull data in. We initially started with a lot of data from Security Hub, which is AWS, and it feeds in a bunch of findings and checks. And we said, this is good. We have a lot of data. We wanted to store it long term. So we started pumping that into Mongo, and we found it just works. Atlas just worked. We didn't have to do any extra work. Within a week, 1 week, we had integrated it and pushed it into production, and it was running. That's not exaggeration. That's actually what happened. We switched over, and it started working. We found it to be reliable and fast, and it could handle the load. And it was doing exactly what we predicted it would, which is a great feeling. So from that, we push all the data in. We have a big data store. We found we could start looking at dashboarding. So we could start doing big aggregations, roll it up into something that teams could drill down and say, how am I doing across my 100,000 objects out of millions? We could then drill down even further to specific checks. That really helped out. Then we said, great, what about searching? So they'll be able to search on individual resource. I have an EC2 instance. Is it secure? We wanted to drill down to that data. Awesome stuff. Then we had reporting. On the other side was the compliance subject matter experts. They wanted to get ready for audits. They wanted to see what the world looked like at any point. So they wanted to dump all of that data out in big chunks and pour through it and say, yes, this matches what my expectations are. And then the big surprise, and this was huge, and we didn't expect it, was the BI connector. We said, oh, this is a nice feature. And we turned it on, and then we hooked ClickSense up to it. Now we have not one, but 6, 10, 12. The teams keep adding on and doing their own charting. They can drill down the data. We've had to do no work. We've enabled our entire org now to drill into the data that we've collected so they can see their own view of their own world, and that's made their lives tremendously better. So the big takeaway from MongoDB Atlas was, let's get something that just works. It's reliable. It actually performs the way we expect, which is we wanted something that ran like local Mongo, but on the cloud. I didn't want to have to do with scaling. I wanted to click a button and have it scale up. We scale really doubles. Our data doubles. And it's not occasionally, it's constant. So the biggest takeaway from all of this, the huge part of this, is our compliance subject matter experts were going quarter by quarter. They would start at the beginning of the quarter, start working on compliance and security issues, and at the end of the quarter, they would finish. They spent the entire time chasing teams to solve issues. This went down to 11 days. 11 days. It's enormous. The value, because when you give a developer a problem immediately, they can solve it while they're in that headspace. If you wait, it's a foreign thing. It's going to take way longer, way more time. So yeah, and we're continuing to improve this. This is something we constantly go after. So, all right, thank you. Appreciate your time. Thanks, Andrew.
Thank you so much. Thank you so much, Barry. Incredible journey and incredible company, Intuit. So this is the fun part of the program where I get to talk to you a little bit about what's new, what's everything that we've been working on over the last year, and what are we launching. So let's break it down into the 3 key tenets of our developer data platform and start with the first one, the elegant developer experience. There's so much we're doing here, I can only do a couple little highlights. One great example is what we've been doing around our local remote experience with the Atlas CLI. Another great example is what we've done with our Atlas Data API. I wanted to tell you a quick story about this one. Within a couple of weeks of the Atlas Data API being generally available, a member of the Roblox community created a connector for Roblox to Atlas via this Data API. And if anyone in the audience has kids, you might be aware that your kids are learning to program. They're learning to code in Roblox and other things like it. And I bring this up because it's a sign of ubiquity. These are the developers of the future. You're going to be hiring these people in 10 years, and this is about This is really a movement, right? Thinking about this model and just broad-based ubiquity. We bring that approach to our programs in academia and our MongoDB University, and just making us so ubiquitous that you can all learn and everyone over time can be welcomed into this community. But today, I wanted to do more of a deep dive on the serverless topic. We've all seen the shift towards higher levels of abstraction over time. We started out with physical servers, we moved up into virtual machines and cloud instances, and that was a game changer. We really unlocked a lot of the value of cloud from that. And over time, we moved into containers, and we got better economics and portability from that. And we've seen the rise of these serverless architectures that move it to that level where you're basically thinking in terms of events and queries and functions, and you're not even thinking about capacity planning at all. Well, this trend is only going to continue. It's an inevitable trend. It's just about making it easier. But serverless databases, which is of course a critical part of this, they've been leaving developers wanting more. Let's talk about that for a moment. Most of the serverless databases that exist have had limited functionality. They're typically key value stores, so they don't have that strongly consistent secondary indexes or transactionality. They typically have some trade-offs. Either you can scale down to 0 and continue to pay, or you have to pay a cold start delay when you do come back online. And typically, they're very hard to deal with from a cost perspective. Basically, your bills will run out of control very easily because typically the bills run linearly with the workload. And finally, these models tend to have a lock-in component, whether it's to a particular provider or deployment model. And if your application's needs evolve, which is very common, maybe you start with a smaller use case and need to grow to a larger scale, this can be a problem. This is why we were so excited to announce the general availability of our Atlas serverless instances. This gives developers what they want, an easy way to get started, a higher level of abstraction in just a couple of seconds. It's a serverless database without the compromises. Let me explain what I mean. With the MongoDB Atlas serverless databases, you get the full power of MongoDB, transactionality, secondary indexes, strongly consistent, et cetera, aggregation. You don't have to pay that scaling trade-off. When your workload drops down to 0, you're not paying anything except for the cost of storage, and you will not experience a cold start delay when the workload comes back. And we're going to build in daily usage-based discounts up to 90% off for read processing units so that your cost curve feels reasonable. You don't have to worry as much about it raining out of control. And when or if you feel like Atlas serverless is something that's no longer servicing your needs, you can easily move to Atlas dedicated from there, and it's available on the big 3 cloud providers. So couldn't have been more excited, and I just love seeing the level of adoption from our developer community on this capability. The next big tenet of our developer data platform is the broad workload support. Being able to do more, not having to pay the operational cost of bolting on all these different systems. Being able to do more behind that single, elegant interface. And to explain this, to make this more, I think, real and fun, we're going to talk about a hypothetical application. We are going to imagine for a moment that we together are building a disruptive technology called Leafy. This disruptive technology called Leafy is going to disrupt the houseplant market. We're going to go down to Sand Hill Road. We're going to get venture capital from blue chip firms backing us. We're going to go take on houseplants. Let's talk about what we're going to need to think about if we're building Leafy. Leafy is the typical dual-sided marketplace. We've got sellers, we've got buyers. Their experiences are both profoundly important. And then we have our own experience. We're Leafy Corp, all of us. We're building this wonderful disruptive application together. We have to think about our own needs. Okay, so let's talk about the buyer's view in a typical application like Leafy. Like all e-commerce applications, and frankly, increasingly like most applications, search is the front door into this application. Finding the relevant results, ensuring that people find what they're looking for and transact based on what they wanted. It's critical to business value. We just take it for granted. But building this capability can be complex. Typically, you have to deal with moving data out of your transactional data store, synchronizing it into a separate search engine. That's brittle. You have to now sprawl your application across multiple interfaces, multiple query syntaxes, different APIs. This can break down. 20 to 30% of a team's time goes into just managing this plumbing. And frankly, a lot of application teams just don't have the sophistication to do this at all, and so they won't build search in, and they won't experience the value that is so, of course, critical in an application of search. This is why we were so excited a couple of years ago to launch Atlas Search. It's the easiest way to build rich, fast, relevance-based search experiences for your applications. It's right there, part of the Atlas experience. You don't have to worry about synchronizing data to another system. We do all that for you. You don't have to worry about learning a new query syntax, a new API. It's accessible through the main MongoDB query interface, all right at your fingertips. We've seen incredible customer excitement about this, and this has been great validation for us to keep investing here. And so we've been doing so much. Since we GA'd in 2020, added stored source fields, cross-collection search, support for embedded documents and arrays, the rich structure of MongoDB. And I'd like to talk to a couple capabilities in more detail. Earlier this year, we moved to general availability. Atlas Search powered Facets. Facets, it's that classic experience, any catalog use case, any e-commerce use case. I can filter in the left nav based on whatever category I want. I can see how many items are there with counts, super fast. Facets are easy with Atlas Search and 100 times faster than how you would have built this before, right at your fingertips. And more like this, the classic experience in an application where you're looking at an item and you're looking at other ones like it, or other people who bought this might have also bought that, or you're looking for a destination, here's a recommendation for you. You can build those kinds of rich experiences on the power of Atlas Search with more like this. So if search is the front door of practically every application today, then I would say mobile and devices are the single pane of glass that we're all interfacing through. And this is a critical topic, certainly for Leafy too. Buyers and sellers selling houseplants on the go, of course. So I'm excited to share that it has never been easier to build a mobile application on MongoDB. There's 3 common models to do it. You can build your own back-end API stack, whether it's a Node Community MERN stack or a Java stack or a .NET stack or et cetera. Or you can take advantage of our Atlas App Services, fully managed API experiences, the Data API, GraphQL, and have your mobile client connect through that, all built into Atlas. And finally, the third, and what I consider the most elegant, industry-leading offering, you can build on the power of Atlas Device Sync. Atlas Device Sync allows you, as a mobile developer, to read and write locally from the client device to the Realm Mobile SDK, which offers an elegant live object model on that device. And Atlas Device Sync will handle all the heavy lifting, all the plumbing, all the error handling, all the stuff that you'd otherwise have to deal with to get that state from that local client device bidirectionally synced back up to the mothership in MongoDB Atlas. This is, we believe, the most elegant solution in the industry, and one that will allow you to build those mobile applications more quickly than ever before. It's not just mobile, by the way. It's tablets, it's kiosks, it's anything that you interface with in the physical world that's digital. Capabilities that we've been introducing in Device Sync are many. Earlier this year, we moved into general availability, what we call flexible sync. This allows you to essentially express what you're going to sync down to a device based on a query. So I can sync a particular person's appropriate data, or a particular role, or a particular store location, et cetera. Super powerful. We've moved into preview, asymmetric sync. This is one-way sync, where data is being generated on a client device, and then typically think of an IoT use case, for example, and that data is being pushed one way back up to MongoDB Atlas, where there it can be stored in a time series collection for rich querying. And as that data ages out, you can optionally use this with the Atlas Online Archive so that the economics move into object storage over time. And finally, earlier this year, we launched the Kotlin and Flutter SDKs for our Atlas Device Sync and Realm offering. These are the emerging next-generation standards for cross-platform mobile development. Okay, let's go back to Leafy for a minute. Another critical part of any application like this is those real-time insights. How many buyers, how many other people are looking at this listing? How many items like this sold recently in the buyer view? And in the seller view, how much have I sold? And who's buying what? And what are the price points? Fundamentally, these are real-time business insights that are built into the application. These are application-driven analytics. You could build this type of thing by bolting on special purpose solutions and, again, dealing with that plumbing and tax. But why? Why should you have to do that? when MongoDB has always had wonderful primitives to enable application-driven analytics, the power of aggregation, secondary indexes, the power of workload isolation from special replicas, and so much more. We continue to invest to make this easier. A great example of this is window functions, which came in MongoDB 5.0. In MongoDB 6.0 earlier this year, new accumulators and operators, richer parts of the aggregation language. And analytics nodes that I mentioned in Atlas give you that workload isolation so you can have the special analytics part of your workload never interrupt the operational transaction parts of your workload, never be in resource contention. And earlier this year, we were excited to announce that Atlas analytics nodes can now be independently scaled from the rest of your Atlas cluster. Kind of a no-brainer, I'll admit. But it's a very nice to have because you can independently scale the analytics part of your workload. And just right there, so easy to use. We realize, though, that there's a lot more we can do to keep enriching the power of application-driven analytics. A common use case with analytics is to combine data from multiple collections. Let's be honest. We have $lookup for this. Well, with MongoDB 6.0, we made $lookups way faster, order of magnitude speed up, by rewriting the query processing engine that powers the back end of these capabilities. We also made it so that $lookup and graph lookup now support sharded collections fully. This is a big step forward so that you never have to feel that anxiety of wondering, can I use this capability or might I eventually need sharding? We want to move past that as a company. That's a super important part of our North Star. But we think we could do a lot more with analytics. It's not just what I've mentioned so far. And another major thing that we're working on, coming soon, is column store indexes. We're going to bring the power of column store for aggregations, much faster ad hoc queries on fields that are indexed. And we're going to do it in a way that's native to the document model, supporting arrays, nested objects, and polymorphism. This is coming soon. Stay tuned. So let's go back to the seller's view for a moment. What's going on here? Well, we've got lots of action, lots of houseplants being bought and sold. Let's imagine that this market is really heating up. I mean, it's getting so intense that the traders, the Wall Street types, they're starting to get involved. People are starting to get involved in arbitrage on houseplants. This is the real deal now. Well, what's going to happen? People are starting to sell commoditized houseplant swaps and all this stuff. What is that? To enable that possibility, we're going to need to be able to have more intensive volumes of data, more real time than ever before, and it's going to be time series data. That's why we launched in MongoDB 5.0, first-class support for time series collections. And we were just getting started with that launch. Over the last year, we've added so much. Densification and gap filling. So if you have a sensor that blips out for a bit, your query still works. Support for sharding. Support for online archives. So you, again, move to object storage economics as the data tiers out. And with MongoDB 6.0, a bunch of critical indexing improvements, support for secondary and compound indexes, and a bunch of read performance improvements. Time series is a huge focus for us. You'll see us keep investing here in the years to come. JB Hunt, I mentioned earlier, those supply chain heroes that helped us get through that challenging time that continues in many ways. JB Hunt's one of these critical providers. We don't think about them every day necessarily, but they're making it possible for you to get the stuff that gets to you, right? They leverage time series to make sense in real time of the whole supply chain and make it possible to do freight forwarding more efficiently than ever before. So in summary, MongoDB Atlas provides a comprehensive, unified platform for application-driven analytics on the foundation of the rich power of our aggregation, document models, secondary indexes, special analytics node replicas, with faster $lookups, new accumulators, time series collections, and column store indexes coming soon. But let's go back to Leafy for a moment. We've talked about our buyers and our sellers experience and those application-driven analytics experiences. But what about us? We're Leafy Corp, right? What about the rest of what we need? We've got a bunch of stakeholders. They're not all software engineers. Sure, the data is born in the application, and therefore it's living where the transactional store is in Atlas. But we've got business analysts and data scientists and data engineers who need to do their thing. Data scientists want to build models to recommend particular houseplants. Business analysts need to know the trends. Where's the market going, et cetera. So when we think about these different constituencies, well, there's a variety of things that they could do. A basic thing they're going to want to do is build visualization, dashboards. They can do that a variety of ways. With Atlas charts, they can build beautiful visualizations and embed them. Or if they prefer, they can build with Tableau and Power BI. That's great. But to build a traditional, to really fuel this lifecycle traditionally, you'd have to have all that data start in the transactional store, and you'd have to then plumb it out and do a bunch of ETL and ELT, and data engineers spend a ton of time on this stuff. And then, of course, downstream from all of that, the business analysts and the data scientists are enabled. And the reality of this model is they're typically getting data that's delayed, it's brittle, it's hard to keep it current. And this model makes it hard to build software on top of software where you want to make automation that actually takes the actions based on the insights. It's not only about having people look at a dashboard after all. So we think that there's fundamentally a better way to deal with this lifecycle problem. And I'm super excited to invite you to the stage, the man, the legend, the voice of the MongoDB podcast, Michael Lin, principal, developer, advocate at MongoDB. Thank you, buddy.
Thank you so much. I'm so excited to be here today. And thank you all for coming out. Thank you, Andrew. I am so thrilled to be able to talk to you about two brand new features in Atlas. Features that I believe have the power to change the way you and organizations like yours interact with MongoDB and the Atlas Developer Data Platform. Now, Andrew talked about Leafy Corp. Massive business. It's an international company now. And they want a real-time dashboard to display the overall state of the business at any point in time. And to do that, knowing it's an international business, they're going to need to enable their users to list plants in multiple currencies. So what's the challenge around that? If we think about it, they're going to need to incorporate not only data from their production Atlas clusters, but also from external sources. So we think about multi-currency, you probably need to incorporate live foreign exchange rates. So imagine having to incorporate those. Fortunately, the first feature that I get to talk to you about today makes that simple. Data federation. It's going to give you the ability to incorporate not only data from your live production Atlas clusters, but also from external data sources. And I'm going to show you that today. Data federation is accessed from the side menu here in Atlas. It's going to give you the ability to create virtual MongoDB instances populated by virtual databases containing virtual collections. Now, these collections are going to give you live access to not only your Atlas data, and data in Atlas Data Lake, by the way, which is MongoDB's fully managed, cost-effective solution to large-scale analytics and data tiering, but also access to external data sources as well, even other databases. So I'm going to show you this in the GUI, and I'm going to do this leveraging largely the GUI. I might dump into the shell, but I realize that as engineers, we're most likely going to do this with APIs and configuration as code. Trust me. It can be done by that. You can configure this using those things, but it makes for a much less compelling demo. So let's jump in. I'm going to click Create Federated Database. And the first thing I'm going to do is change the name of the default instance from the imaginative Federated Data Instance 0 or something to something that means something to us. Leafy Lake, we'll call it. Next, I'm going to add a data source. Now, the first place we need to get data from for our real-time dashboard is going to be Atlas cluster. So I'll choose that, and I'll select the cluster where that data lives. Next, I'll expand LeafyDB to expose the collections where I want this data, and I'll select all of those collections, making those available to our federation instance. Next, I'll change the name of the database, again, something that means something to our business, LeafyDB, and I'll change the virtual collection name as well. Here's where we're going to pull in sellers data from our Atlas cluster. Next, I can drag the reference to our LeafyDB sellers collection from the live Atlas cluster and make that available. Now notice I'm not copying any data. I'm just configuring federation so that when a query comes into our virtual collection, it goes to the live cluster. Now, the next place we need to get data from is that foreign exchange data. So I'll create a virtual collection to represent that. I'll call this collection live FX rates. Next, I'm going to need to add another data source. And I've already shown you how to attach a live cluster. There are two additional external data source types. S3 is going to allow you to present files stored in Amazon's S3 object store. So imagine JSON, BSON, CSV, TSV, even highly compressed file formats like Parquet, available as a virtual collection in MongoDB, right alongside your data. But that's not even the most interesting option here. This one, HTTPS, is going to give us access to fetch a file from a web server and treat it like a virtual collection. Mind-blowing when you can this simply give access to not only your Atlas cluster data, but external data as well. Let's go through an example, and I'll show you how it works. I'll name my cluster, or my data source, live FX rates. And Leafy Corp, because they're a multinational company, they have subscribed to livebizData.de, who, among other things, are going to give us live access to foreign exchange rate data via an API. They've given me an API URL and an API key. I'll paste that in. I'll click Next. And then I will drag and drop that reference into our virtual collection, and I'll save this. Now here's where I think I'm going to go a little rogue. So I've done everything in the GUI up to this point. I want to jump into the shell. Now, many of you are going to be familiar with Mongo Shell. Some of you may not be, but hang with me. The MongoDB shell is really nothing more than a Node.js instance configured to listen to code that I type and display the results. And I'm doing this to show you that these configurations, these capabilities that are available today are available at the very lowest level of the stack. Every API, every SDK now has this capability. Let's jump in. First thing I'm going to do is authenticate. I'll paste in my login and type my password. Here I am in Leafy Lake, the LeafyDB database that I just configured with the federated database. I'm going to do a show collections, and there are the two collections that we just configured. One of them from a live Atlas cluster, and one of them from an external data source. Let's take a look at DB sellers. I'll do a find one, and we'll take a look at the seller document. Now here we are, Elizabeth Moyo, she's a seller. She's listing plants in the Zimbabwean dollar, ZWL. Take note of that. We're going to take a look at the foreign exchange rate for that shortly. You can see the plants she's selling along with the prices and the quantities she has available. Here's where the magic comes in. Now, I'm going to take a look at live FX rates. That's the collection we just configured. Now remember, the live FX rates collection, the virtual collection, is really a virtual collection on top of the API. So when I do find one, it's returned a document. It's returned data, and it's formatted as a document. So I've got one currency per field in the document. Now I'm going to do it again. Take a look at that ZWL and watch as it changes. It's changing because it's a live data feed. It's calling the API in real time. Super powerful for our real-time dashboard, right? So let's do it one more time, and you can see it's pretty dynamic currency. But really, the data that's come back is given to me in one currency per field. It's probably not the best shape for me if I want to begin extracting that data and doing computations for our dashboard. So the fortunate thing about data federation is it's got an answer to this problem. We can apply views on top of the virtual collections to reshape the data. Let's configure one, and I'll show you what I mean. I'm going to click Add View next to our live FX rates virtual collection. I'll name my view. Let's call it FX table, because it's going to be more tabular. And here I'm going to paste in some aggregation code. Now, some of you may not be familiar with aggregation code. That's OK. You don't need to be concerned about the syntax here. Let me just run through this, and I'll show you what I mean. I'm going to flatten that document out so that it's one currency per document rather than per field, so that I can more easily do a lookup on it. I'll save this. Let's jump back to the shell. And let's take a look at our collections now. Now what I've done is I've created a view. You can see it there, FX table. It's marked as a view. This is going to allow me to reshape the data as it comes in. And if I take a look at that data, if I do a find on that, it's going to show me all the documents. Voila. One currency per document. So much easier to do a lookup on, a find, and begin doing computations with it. I'll show you the data again. It is live. It is showing live data, so those values are going to change. Now, how do I use this data? Rather than walking through every stage in the pipeline and trying to explain it, I'll show you visually what's happening. We're going to extract the currency code from the main document, and we're going to do a lookup on that table that we just created. Remember, the table is now a view on top of a virtual collection, on top of an API call. We'll extract that, and we'll insert it into the document. We'll insert the exchange rate. Then we can compute the dollar price by dividing the exchange rate by the price for the plant. Then I can begin to do some interesting things like group by plant to compute the max, min, and average price for the plant, as well as a total stock count. Now, this is amazing capability. And if I were to do this in code, it would look something like this. Paste that in. Now, some of you, when I pasted this in, may be trying to read the code. There's the result. And what if I wanted to take this and create a materialized view, reuse it, send it back to my end user cluster so that end users can review their average price, average sales price? We could do that simply by appending a dollar out, thereby creating a materialized view and sending it back to the cluster. Now, all of this is wonderful, and I saw some of you, as you looked at the code trying to figure out what was going on, some of you may even have lost interest a little bit. I get it. I get it. Some of you don't know MongoDB query language, and that's okay. The data analysts among you may not know MongoDB query language, but what do data analysts know? What do they work in and day out? They most likely know SQL. So what if I could define a SQL string like this that I've displayed here, copied that in, and what if I could run that SQL against the Atlas cluster like this with a little helper function? There's our results. Read-only SQL in the shell, available at the lowest layers of the stack, available to every API, every SDK, every integration that has access to MongoDB now has access to this capability. I, for one, am super excited to see what you build with this. Now business analysts using Tableau have this capability. Data scientists using Jupyter Notebooks. Back office analysts using Excel. Business analysts using SAS. Every integration, every tool, every layer of the stack now has access to this capability. I, for one, am so excited to see what you all build with this. Now, before we bring Andrew back up, I want to make sure I invite you to listen to the MongoDB podcast. A little bit of self-promotion here. Listen and subscribe to the podcast wherever you get podcasts for insights on how customers are deriving product value, deeper dives on products like this, new innovations and product capabilities. Later today, I'll be sitting down with Surya from Harness to talk about how they've migrated from MongoDB Community to Atlas and how they're getting product value, how their out-of-the-box performance-related dashboards enabled Harness to understand how their system was behaving at scale. And with that, I'll turn it back to Andrew. Thank you.
Thanks, Mike. That was great. So if we think about what Mike was showing us, he's showing us as a builder that we can wear that hat now of a data engineer if we want to. We can use the power of data federation to get data from disparate data sources and dollar out that data into, for example, an Atlas cluster where we can operationalize that data in our applications. A very powerful concept. And of course, many of our peers do this type of work, data engineering and others, full time. This is why we've introduced more and more capabilities to service the entire data lifecycle. In summary, Atlas Data Lake for large-scale analytics and object storage economics on historic data. Atlas Data Federation, the ability to create these virtual views of disparate data sources and do those data engineering tasks and dollar out into the destination of your choice. Atlas Charts, beautiful embeddable visualizations that you can put into your own applications or your own internal dashboards. And the Atlas SQL interface that allows the people who know and love other tools, Tableau, Power BI, and others, to have a direct way to get access to data in MongoDB Atlas clusters and in Atlas Data Lake. Okay, so we've created this disruptive houseplant application, and it's just been a game changer. We Leafy, like all companies, there's something that we just all have to worry about that we haven't talked about yet, and that is the fundamental critical thing for all of us, that is security. What about supporting our most sensitive workloads? Well, I'll tell you, it's been amazing to see over the years just how many companies have been built in the security space on MongoDB. It's just a huge, huge area for us. And before I go into some detail on a topic, I wanted to do a brief interlude and give a shout out to MongoDB for Startups and a wonderful company that's a participant in our MongoDB for Startups program called Vanta to tell you a little bit about what they've been building in the security space. Let's watch a video.
My name is Robbie Ostro. I've been at Vanta for 3.5 years now. I was the first employee, first engineer, and now I am the engineering manager on the platform team. Vanta is about automated security and compliance. At the end of the day, historically, how security has worked is that a company will get a piece of paper once a year, then an auditor looks at and says, "You guys seem secure, that's great." We check all the same stuff that an auditor would check, but instead of checking 1% of stuff once a year, we check 100% of stuff once an hour. And so we're trying to codify every little bit of security knowledge that not everybody might know and allow you to apply it to any system, ensuring that you're always following best practices. The most important thing to us is being able to iterate quickly, both on the number of features and on the number of integrations that we build. And MongoDB has been really instrumental in allowing us to develop quickly, build quickly, and ensure that we ship quickly without any downtime. We originally chose MongoDB because it was a perfect tool with which we could prototype. But as we grew, we realized it was also the perfect tool that was able to scale with us. One thing that MongoDB for Startups helped us with was actually sending us a consultant who was able to help optimize the way we were using MongoDB and giving us a report with excellent advice across the board. We still refer to that report all the time. One awesome thing about MongoDB Atlas is it has a feature called VPC peering, which allows us to take our VPC, communicate with our database cluster while not exposing any extra cruft to the world.
One key benefit is MongoDB's API abstractions tend to feel like JavaScript and JSON objects, and we really enjoy trying to make our entire stack feel and look like TypeScript. So MongoDB cosmetically, aesthetically, and even programmatically feels like working with JavaScript the whole way down. I really appreciate that MongoDB Atlas allows for fine-grained roles using AWS IAM permissions. I'm particularly excited that MongoDB Compass now also supports authenticated Compass using AWS IAM roles. So we can now leverage all of our SSO work on AWS for fine-grained access to MongoDB.
Whenever we make changes or whenever we need to think about how we want to model our information, MongoDB has the flexibility to let us make changes on the fly and to speed up our development process.
Here at Vanta, we're securing the internet and making sure that the incentives are aligned such that everybody wants to do so. We're hiring quickly and looking for great new engineers, so give us a call if you're interested.
Vanta, fantastic. Securing the internet. It's a perfect segue to what I wanted to talk to you about. Supporting our most sensitive workloads. Do I have your permission to go through a little bit of a history lesson on securing the internet, in particular focusing on encryption? Let's talk about this. Over the years, encryption means a lot of different things to a lot of different people, but at the brass tacks level, I think mostly it's about TLS encryption over the wire and encryption at the storage tier, encryption at rest. Transit and rest. These days, this is just non-negotiable baseline. If anyone in this room is building applications that don't take advantage of this at baseline, we got a problem. And I know how hard this can be in self-managed software stacks. This is one of the key advantages to moving to levels of abstraction that give you this out of the box non-negotiably. But if you think about it, this model, it's a really good baseline. You know, in 2022, this is non-negotiable. But there are still some gaps. Let's talk about them. Instead of sweeping them under the rug, let's talk about them. If you think about it, a typical situation in which you have users interacting with a client application that's interacting directly with a database interacts with storage, even if you've got everything encrypted over the wire and encryption at the storage tier, typically your database will be decrypted in memory. What this means is there are a couple threat vectors to consider. You could, for example, have a malware situation on the box. You could have a bad actor in a service provider. Or you could be subject, for example, to a CPU side channel attack, among others. The reality is there are going to be vulnerabilities. Not everyone's going to worry about this, but for those most sensitive workloads, this matters. We introduced our client-side field-level encryption in 2019 to really improve the situation. Data gets encrypted in the application before it goes to the database. The problem with this, though, is you give up a lot of that query functionality. We wonder, is there another way? Is there a world in which you might be able to have encryption in the database, but still have encryption in use and still have rich query functionality while having encryption in use? And we believe that there is a way. We're on a multi-year journey to prove it out. We've brought in industry-leading researchers from academia to pioneer this in our cryptography research group. And we call this, something we launched into preview earlier this year, queryable encryption. We're starting with a key step forward, which is randomized encryption with a quality match. Let me explain that. In a typical situation, I might have, say, a social security number and it's going into a database. The database is going to store ciphertext. In other words, the database can't make sense of what the social security number was. What's great about randomized encryption is that the same social security number showing up in two separate documents will have different ciphertext on the system. Okay, cool, guess that makes sense. But the fact that the database can do an equality match on this without knowing what the social security number is actually really quite revolutionary. And this is just step one for us. We're on an encryption journey. It started with bringing in those researchers, building that cryptography research group, starting with that first capability I just mentioned, equality match on encrypted fields, randomly encrypted fields. You'll see us in the months and years to come introduce way more capabilities here. Range queries coming later this year or early next year. And over time, prefix, suffix, and substring match. In summary, you'll be able to encrypt your fields and still run rich expressive queries on them. And we're going to do this out in the open in the daylight. That's the way security is done in the right way in industry. We're leading the industry on this. And we're doing this while doing everything else that we're doing because we know that this is how you can bet on this platform for your most sensitive workloads in the years to come. Okay, so we've talked a lot today about this idea of having an idea like Leafy and going global with it. That's awesome, it's inspiring, it's empowering, but we all live, I think, in a real world where not everything is greenfield new stuff for us. Some of us are probably dealing with systems of record that have a lot of high-value data in them that have been holding us with a lot of inertia for years. You need to be able to build around that data. It's just too vital to your business. But it's been really hard to make change. It's hard. So our goal is to make it easier. We're realizing that you've got hundreds and thousands of these tables defining all of your schemas. This is that quagmire that makes it so hard to make changes. But we know that you can actually, it's not that difficult to remap a tabular schema to a developer-oriented embedded document model. And there's profound performance and cost and scalability benefits of doing this on top of all the benefits, of course, for the developer and how we reason about the data. And so we've been super excited to launch into preview this year our Relational Migrator. Relational Migrator analyzes your traditional schemas, models the new modern document schema, moves the data, transforms it, and does that for you with no downtime. So global reach and scale, the final tenet of our developer data platform. We have had our own journey of global reach and scale. When I think about Atlas, we started in 2016 in 4 regions on one cloud provider. Flash forward to today, we're available in over 100 regions on all 3 cloud providers, the most widely available data service in the world. We just launched, for example, on Google Cloud in Milan, Paris, and Madrid, our first launch in Spain, and it just never stops. More and more reach all the time. To give you an example of just how wonderful it is, we've got so many wonderful new customers coming on and building their great ideas on top of the platform. In literally just the last couple of months, a random example, and it could be a completely different subset if we were to do it. In the last couple of months, we've seen a healthcare simulation startup launch in Norway. We've seen a bank for Vietnamese youth on a mobile app launch in Vietnam. We've seen a cutting-edge dating application launch in Chicago. We've seen an application optimized for enabling folks to sell surplus food from restaurants in Mexico City. And an NGO in South Africa launched a crowdfunding platform for livestock. More and more amazing ideas being built all around the world, on top of that incredible number of people signing up for Atlas every single month. We couldn't be more excited to see what you in particular, the disruptors of the world economy, are going to build next. So thank you so much. Thank you for being with us today, and look forward to you having a great conference.